Hello everyone, my name is Corey Burns and my drug is diphtheria. What diphtheria is an acute and highly contagious bacterial disease that causes inflammation of the mucous membrane. As depicted in this image here, the lady's neck is enlarged and swollen due to an immense amount of bacteria buildup in her air passageways. It is rare in developed countries due to immunization and advances in medicine and technology, and is really only prevalent in third world countries nowadays. A very prominent antibiotic associated with diphtheria is erythromycin. Erythromycin treats bacterial infection and inhibits its growth. It falls under the group of macrolids due to its 15th centered membrane. All macrolids attach to the 50S ribosomal subunit, which is referring to its mechanism of action, which blocks the ability of the ribosome to synthesize the polypeptide chain. The drug carrier I chose to use is inorganic nanoparticles with an emphasis on copper. Copper is an essential micronutrient, and diphtheria can occur from copper deficiency. So what better way to get rid of copper deficiency than injecting someone with copper? Now, Corynebacteria diphtherium is the bacterium associated with diphtheria, and what copper will do is enhance the binding sites associated with this bacterium. Now, the mechanism of diphtheria is quite complex, and it generally happens in 5 major steps. The first step will be processing. That's where the leader region is cleaved during secretion, and proteolytic nicking separates A and B subunits, which remains joined by the disulfide bonds upon reaching cytosol. In step number 2 is binding, and binding is just that. The toxin binds to heparin-binding epidermal growth factor precursor. In step number 3, the complex undergoes endocytosis by the host cell. In number 4, acidification inside the endosome induces translocation of the A subunit into the cytosol. Disulfide bonds are broken and B subunit remains in the endosome as a pure substance. In step number 5, a subunit ADP ribosylates host EFF2 is required for protein synthesis. When it is inactive, the host cannot make protein and thus dies. Alright, as mentioned in a previous slide, Corynebacteria diphtherium is the bacteria of diphtheria. In this picture, it depicts 3 different sites, which kind of shows the molecular level that diphtheria and Corynebacteria bind on. In the picture, red represents the catalytic domain, B is the binding domain, which displays the receptor for the cell attachment, and blue represents the hydrophobic domain, responsible for insertion to the endosome membrane to secure the release of the red seal. Proteolytic nicking of the secreted form of the toxin separates the red and yellow chain from each other. With the yellow chain's hydrophobic translocation region, it is responsible for insertion to the endosome membrane to secure the release of the red chain. And lastly, here are my references. Thank you.